This is Unit 5, Section 5.3. We're going to explore multiplying polynomials larger than a monomial. So before we looked at multiplying by a monomial where we had one piece being distributed in, and dividing by a monomial where we had one piece being divided into each part of our polynomials. Today we're going to look at multiplying polynomials in a larger sense, where maybe we would have a binomial times a trinomial, or a binomial times a binomial, or times itself even. So we're going to look at multiplying binomials, which is more distributing, similar to what we did last time. So if we recall, we had already known how to do a monomial times a polynomial. So if I distribute in 3x times 2x, I get 6x. 3x times minus 5, 3 times minus 5 is 15, with the x coming over, and I forgot, x times x increases because there's two x's being multiplied. Here there's only one x being multiplied. So what if we want to multiply a polynomial by another polynomial? For instance, this binomial times this binomial. Any ideas? And so that idea comes from, we want each piece, the 3x, to be distributed just like we had before. The 3x went with both the 2x and the minus 5. The new part here is that the 2 is also going to be multiplied through. So we still get that 6x squared minus 15x. In addition, now we're going to get plus 4x, and another piece here, 2 times negative 5 is negative 10. So if I take two things times two things, I get 1, 2, 3, 4 items. Now I can look and combine my like terms. Negative 15 plus 4 is negative 11x, and the minus 10 comes down. So when I started, I had 4 terms from my 2 terms by 2 terms, and I combined 2 to get down to a trinomial here. So let's apply that at a larger sense. Anytime we're multiplying any polynomials, not just a monomial, distribute every term in the first parentheses by every term in the second parentheses using multiplication. And then always remember at the end, combine like terms when needed. So I'm going to distribute 6h to the 2h. So 6 times 2 is 12. 2h is being multiplied. 6 times 3, so I have 18. Only one h part of that one. And then I have the negative 7, and I go underneath. Negative 7 times 2 is negative 14 with 1h being multiplied. Negative 7 times 3 is negative 21. Combine like terms here in the middle. I can't do anything with the 12h squared. 18 minus 14 h's is 4h, and minus 21 comes down. On number 2, okay, I'm going to start up here. 5m times 8m, so 5 times 8 is 40. M times m is 2m's being multiplied. 5m times that negative 1 is minus 5m. And then switch to the other piece. 2 times 8m is 16m. And 2 times negative 1 is negative 2. Combine like terms here in the middle, bringing down the 40m squared. Negative 5m. I think that should be positive. Nope, negative 5m plus 16m is 11m. And bring down the negative 2, giving me my quadratic trinomial here. On number 3, we have 3a minus 4 squared. This is not multiplication. This is not distributing in. What we need to do first is break this into the multiplication using the rule of exponents that says any exponent is repeated multiplication. So it's saying take 3a minus 4 times itself twice. Now we're ready to distribute. We can't distribute exponents. We can distribute multiplication. 9a squared minus 12a, and then I'm going to go down here. Minus 12a again, and negative negative is positive. 4 times 4 is 16. Combine my like terms in the middle here. So negative 12, take away 12 more is negative 24a, and bring down the plus 16. Here's my final answer. On number 4, 2n plus 5 times 2n minus 5. 2n times 2n, 4n with 2 being multiplied. 2n times negative 5 is negative 10n. 5 times 2n is positive 10n. And 5 times negative 5 is minus 25. Can't combine anything with the 4n squared, so that comes down. Negative 10n plus 10 adds a 0, and I can bring down negative 25. So what started as 4 terms is now ending as a quadratic binomial here when I multiplied those two pieces out. So each of these situations is a binomial times a binomial. Binomial, binomial. This one, when we have two binomials, it splits into binomial, binomial. And here as well. So our last two examples are, what if I multiply a binomial with a trinomial? 2 terms times 3 terms. 2 times 3 terms, I should get 6 terms and then combine what I can. But we'll do the same piece that we did before, where we have distribute the first piece. So now I have 6 times 2n squared. So I have 12n, 3 times being multiplied, and then go to the next one. 6n with 2 being multiplied, and 6n times 7 is 42n. And then we switch to the negative 8. Negative 8 times 2n squared is minus 16n squared. Negative 8 times n is minus 8n. And negative 8 times 7 is negative 56. Back to our combining like terms. So now, to stay a little bit more organized here, I go back to my underlining. Okay, so I have nothing to combine with a 12n cubed. 6n squared minus 16 is negative 10n squared. 42n minus 8n is, I think that's 34n. And 56 can't be combined with anything else. So now I have multiplied my binomial times a trinomial to result in all 6 terms here. Combining like terms, I end up with a cubic polynomial. On number 2, we'll do the same thing. Now we have 3 terms times 2 terms. So I'm going to multiply here to here. Negative x squared times 2x is negative 2 with 3x's being multiplied. Negative x squared times 3 is minus 3x squared. And then I switch to the next term. 3x times 2x is positive 6x squared. 3x times 3 is positive 9x. And switch to the last one. 1 times 2x, still 2x. 1 times 3, still 3. And then we can go to the combining. I have 3x's, 2x's, 2x's, 1, 1, and a constant. So these ended up being next to each other to combine. Negative 2x cubed minus 3x cubed, negative 2x cubed doesn't combine with anything else, so I can bring that down. Then I have negative 3x squared with positive 6x squared, which gives me 3x squared. 9x plus 2x is 11x. And the positive 3 doesn't combine with anything, coming down as that constant piece there. All right, so now we've extended our understanding of multiplying not only by a monomial, but by a binomial or a trinomial. Use colors if you need to, like I did, or make a way that you can stay organized so that in the end we have all the pieces that we need. Draw the arrows so that you know you can come back to it if you have to stop or get interrupted. Let me know if you have any questions on the practice,